Scott's Geography Notebook. Do you want to try saying it?
Da, da, da.
We see a few other very cool things in the atmosphere that relate to optics, that relate to light. And those are referred to as light emission. There's two examples that we want to highlight in our atmosphere. But before we go there, we're actually going to need to delve into some dark and scary territories. The first one is going to be chemistry. And the second one is going to be physics. No! Wait, I thought we were in geography. We are, but here's the deal about geography. We don't like to tell you very often, but geography just kind of takes all of the other sciences and gives and makes it more holistic, kind of brings it all together, right? So the chemists are going to be talking about what they talk about, the physicists are going to be talking about what they talk about. We're going to bring both of those together and talk a little bit about it. Well, in chemistry, the main thing that we love talking about, that the chemists love talking about, are the atoms. Okay, so what do we know about an atom? Well, we're going to have our nucleus, and inside our nucleus, we're going to have neutrons and protons, and then we're going to have, zip zooming around these guys, any number, and boy, do those chemists love them, any number of electrons. Okay, so you might remember there was a first shell, second shell, blah, 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 2 in the first, 8 in the following. That's all we need to know, right? Electrons are going to be zip zooming around. Where's that? With that thin pen that we can do some nice zip zooming around with. Zoom, zoom, zoom. Okay, and then there's a little bit of pull, right? So the electrons have a negative charge to them, and the nucleus has a positive charge, and that's what kind of keeps them all kind of centralized right there. Do they ever move away? They sure do. Okay, and that is when they're hit by an outside energy. Wah, 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 wah. Now, I know yellow I've used for sunlight before, but here we're just going to make this very generic energy. In fact, we're going to be talking about a number of different types of energy that can hit these guys. Okay, so let's talk about one example of what can happen, right? So, okay, and then what happens when these guys hit by energy? These electrons, they get very, very excited. And so if our little atom is set up like this, with 1 or 2 or 4 or 5 electrons, and then it gets hit by energy, these electrons are not only zip zooming around, zoom, 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 but they get more excited. And so what starts to happen is they move further out. Their speed is increased, and so they move further out. Now, in our example that we're looking at, they're not quite leaving, right? If they leave, then yeah, they can do that. But what we want to look at is what's happening here. Okay, this is the electrons getting excited. So excited electrons. Why? Because they've been hit by energy. All right. Well, let's talk about a few different examples of what happens. All right. So, before we get into that, what happens eventually? Okay. Once time goes by and the energy is dispersed, right? The energy is used up by all these electrons flying and zip zooming all the way around. Then eventually, we're going to be coming back down to our ground state. Okay, now, if I'm giving you nightmares of your chemistry class, know that it does get cool before too long, okay? So they're back down to the ground state, and they're back zooming around because there was always that pull, right? These are negative, there's going to be positive charge too there. There's always that pull to bring them back down. They settle back down to the ground state. However, in this process of being excited, going back down to the ground state, they give off energy, right? Something is released in the electromagnetic spectrum, right? That releasing of something, and we can talk about what that is as we look at a few different examples, that is going to be the emission. Okay, that is going to be releasing something. Let's take a good first example. The first example that I want to talk about is where we have our campfire. Oh, we need a few rocks around. There's brown. Good. Or maybe those are logs. I don't know. So we have our campfire, and we take the skewer, and we put that piece of metal into the fire, and we put it down into the coals because we're done roasting our marshmallow. All right. Then, after a little while, we pull it out of the fire, and we're holding this piece of metal up. But what we start to see is that the end of the metal is now glowing red. It's releasing light energy. Okay? Those iron or whatever it is that you put in there, that metal heated up, those electrons got excited, but then now it's starting to come back down to its ground state. Yes, it's releasing two different things, right? We know that that sucker is still going to be very hot, so heat or infrared energy, but also some light energy. Okay, cool. So coming back down, getting unexcited, coming back down to the ground state, releasing energy. Let's talk about another example. And this one I want to, let's see, we'll start with a little blue oval. And I'm just going to do a little line right there because then we're going to have the inner circle, right? Something like this. And then it's going to say O-P-E-N, right? So we refer to these guys. I did the open sign, but they've done all sorts of things. This is going to be a neon sign, right? So what happens with that neon sign? Okay? What you have there is a very thin glass tube. And inside that glass tube, somewhere, we're going to be plugging that sucker into the wall. Let's see, we'll do this and then this. Good, good. Okay, and what we're going to be sending in there is electricity. Okay. And neon gives off one color of light. For the other colors that we see in those neon signs, there are other gases that do that. But what happens is the same thing. Those electrons get very excited because they're getting hit by electricity. You'd be excited too. Okay, they get hit by electricity. They get excited. But the emission, what they release as they go back down to their ground state, that's going to be different colors of light. So a neon sign is giving off light. And different types of gases are going to be giving different colors of that light energy. And so that's how they get some of those different colors. Okay, sometimes they cheat and the glass is colored, but usually it's that glass tube and it's going to be different gases that are in there that are giving off different kinds of light. All right, let's get to the atmosphere because that's what is really, really cool. And that's what we're learning about in this class. All right. We talked before about those two different gases. Two main gases that we have are going to be O2 and N2, oxygen and nitrogen. Hey, did you know that these guys also have electrons? Now, there's two of them together, right? It isn't our basic little atom. It's going to be our oxygen molecule, right? But those atoms, or those electrons that are floating around there, I'm just going to draw in a few of these little guys, right? These guys are going to be hit during the day with all sorts of energy from the sun, but making it down to our lower atmosphere, they're going to get hit by light energy. So the incoming energy is going to be light energy. We're going to call those photons. And here's where we start to use some of these physics terms, okay? No fear yet, okay? Light energy comes in, it gets these guys, oh, I'm so excited, and they start zooming around, and I know that it's not just an N with a 2, but electrons and neutrons and protons and nuclei and all that good stuff. But they get excited, and then once the sun starts to go away, right, though they can start to relax a little bit. In another video, I talked about something that's called twilight. And twilight is caused by several different things. What we've talked about in the other videos is that some of it has to do with bending of the light. Not bending of the light, bending the light. Other times it has to do with scattering the light. But then there's one other process. As these molecules, the oxygen and the nitrogen, they've been hit by photons all day, but now it's time to relax, time to go back to ground state. What gets emitted from there? Well, one of the things that gets emitted from there is blue light. Okay. Maybe not as bright a blue as the light that it was scattering before, but as it starts to come back down, we do see some of this blue light. So some of the light that we have in twilight is from the bending of the light, the scattering of the light, but also another process called air glow. That air glow is going to be making it so that it's a little bit brighter, even though the sun has gone down from that release of light energy as the oxygen and the nitrogen go back to their ground state. Okay, one other perhaps coolest function that we see of all of this. In our upper atmosphere, we do have a layer, and that layer is referred to as the ionosphere. Okay, we've gotten into enough chemistry already, but in the ionosphere, guess what we have? We have a lot of ions. Well, here's what happens. From the sun is going to be sending all sorts of stuff to us. We've learned about light. We've learned about all sorts of things. But another thing throughout of sun storms, sunspots, or solar flares, these guys are going to be spewing electrically charged particles. Right? Electrically charged particles. That's not good, right? And so what do we do with these electrically charged particles? Well, as they're coming towards the Earth, our big blue marble that we have right here, we do have what's called the magnetosphere, and that is kind of causing the polarization that we see of our Earth. But what starts to happen to these electrically charged particles as they come in, they are sent towards the polar regions. And eventually they do come in and they interact with what's up here in the ionosphere. Okay? The ionosphere, the particles that are there, the atoms that are there are also, they have their ground state. They get hit by these electrically charged particles. Okay, I'm messing up the colors altogether. These electrons go, whoa, whoa, wow, and they're all zooming out here at this more excited state. But then as they start to come back in, I need the right color, whatever. The bright green. Oh, perfect. It's down here on the ground. Okay. When these guys start to come back in, they start to release light as well. They start to come back down to their ground state. And where's our slide? When they come back to their ground state, when they are emitting light, that light energy is beautiful, what we call auroras. Now, I've seen a lot of the world, but I've never seen auroras. Okay? So we're going to say, let's put a little notes here. We have particles, ions hit by solar flares, electrically charged particles from the sun. Solar flares. That's not good. They get very excited. However, they eventually settle back down, and the emission of light, that is our, well, I mean, they're green. So let's see. Those are our auroras. And I suppose that green's a little bit hard to see. So with the polar auroras, sometimes it's called the aurora borealis for the North Pole and the aurora australis, right? But you see these beautiful green lights going across the sky. Right? It all has to do, both the air glow and the the air glow and the northern lights, that extra light energy that we see, has to do with the emission of light energy as our electrons go back into their ground state. The energy that it releases back out is going to be light energy for both of those.